What does this question say? Cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 upon 35. Now how do we deal with this? Okay, do we no result related to cos inverse x plus cos inverse y? NCERT does not give any such result, but in case you are preparing for the JEE examination, you can use your result of cos inverse, that is when, what do you have? Cos inverse x plus cos inverse y, right? So cos inverse xy minus under root of 1 minus x square, under root of 1 minus y square, you can use that result. But right now, when we are talking about this question from the point of view of NCERT, what are we supposed to do in this case? We are supposed to deal it in a similar manner, right? We know one result to add two ITFs, that is tan inverse x plus tan inverse y, and we'll use that. This is the result that I am talking about. This is equal to tan inverse x plus y over 1 minus xy, where x comma y are greater than 0 and xy, the product is less than 1. This is the result that I am talking about. This is the result that we are looking to apply. Oh, but there is no tan inverse on the right hand side. Why worry about that from the very beginning? We'll convert this in terms of tan inverse, this in terms of tan inverse. You'll add them together. You'll get a result in terms of tan inverse. Yes. You'll convert that again in terms of cos inverse, and you'll get that. Oh, is it so? Yes. Yes. Then let's do it. Yes, let's do it. Let's begin by writing let cos inverse 4 by 5 is equal to theta. Cos inverse 12 by 13 is equal to phi. This gives me that cos theta is equal to 4 by 5. By the way, from here you note that theta, since cos inverse 4 by 5, the output will be theta. The output should lie in the interval 0 comma pi. So this theta lies in the interval 0 comma pi. But since cos theta is equal to 4 by 5, the value of theta will lie in the first quadrant. Right? From first and second, we have chosen the first quadrant, as you can see over here. Right? Since cos theta lies in the first quadrant, sin theta, obviously, first quadrant will be positive. Therefore, sin theta, which is under root of 1 minus cos square theta, will be equal to 3 by 5. Very easily. Right? How did you get that? Oh, 1 minus 4 by 5 whole square, and Pythagoras theorem, you can easily get that, right? Okay. What about this one? Cos phi is equal to 12 by 13. Once again, phi over here, since it is output of cos inverse, it would have lied in the first or second quadrant. The value of cos phi being positive, phi lies in the first quadrant. Therefore, sin phi will be equal to under root of 1 minus 12 by 13 whole square. What does that give me? This is 5 by 13. Simply. Oh, is it so simple? Yes, you can write that very easily. If you may remember the Pythagorean templates, this is 5 by 13. 5, 12 and 13, right? That's what you're looking at. And this gives me tan theta is equal to sin theta upon cos theta, which is 3 by 4, which gives me theta is equal to tan inverse 3 by 4. We wanted to find the value of this in terms of tan inverse. We have done that, yes. Similarly, let's find tan phi over here. Tan phi, mind you. Tan phi is equal to sin phi upon cos phi, which is 5 by 12. Okay, therefore, which gives me phi equals tan inverse 5 by 12. Okay. What next? Since phi is equal to this, therefore, in the LHS, you have theta plus phi, which is tan inverse of one angle, that is 3 by 4, plus tan inverse of 5 by 12. Realize this is less than 1, this is less than 1. The product will also be less than 1. Yes, the product will also be less than 1. Therefore, I can apply this result over here, which is given at the top. Apply that. This will give me tan inverse of 3 by 4 plus 5 by 12, 1 minus 3 by 4 times 5 by 12. This is what you'll get. Right, yes. What next? What's the LCM of 4 and 12? It's 12. Let's take the LCM in the numerator and simplify this further. This is tan inverse. What you get is, in the denominator you'll have a 12. Okay. And this will become 4 times 3, which is 3 times 3 is 9 and 9 plus 5 is 14. Okay. What about this denominator over here? This is 12 times 4, is it? No. 3 times 4 is 12. So we'll have these terms get cancelled. This is what you'll get. and in the denominator, therefore you will get a 16, 16 minus 5. 16 minus 5 is 11 in the denominator, and denominator 16 will go at the top over here. This is what you get over here. This is what you get. This is the value of tan inverse. Can we simplify this further? Yes. This is further equal to tan inverse of, what do you get? 12 and 16. 12 has a factor of 4. Yes, 16 also has a factor of 4. This becomes 3. This becomes 4, right? Okay. And what's 14 times 4? And what's 3 times 11? 56 upon 3 times 11 is 33. That's the question in front of us. Yes. And what next? Can we convert this in terms of cos inverse? Yes, we can convert this in terms of cos inverse. Once again, using the similar ideas that we have discussed over here. I think, okay, this is 33 and this is 56. The denominator should be greater than 56. Okay, there may be some kind of an issue in this 33, but this may be changed, right? Let us check what that value will be, and there's some correction required over here, right? There's some correction required, yes. But let's first get the value, what we'll be getting. Tan inverse 56 upon 33, can I convert this in terms of cos inverse? Yes. Is equal to, let's call this equal to, that's theta, phi, let's call this alpha for a minute. Okay. If this is equal to alpha, then tan alpha is equal to 56 upon 33, which gives me sec alpha can be easily found by the help of under root of 1 plus tan square alpha. What is that? Under root of 1 plus 56 square upon 33 square. This is what you have. 33 square and 56 square, right? Can I add them together? Yes. What I'll get is, let's see, where does that take me? This is under root of 33 and 56 are two very big numbers, two relatively big numbers as compared to when we talk about the normal Pythagorean triplets that we are aware of. If you are aware of these Pythagorean triplets, then it is very good. But if not, let's find that. In the numerator, you'll have a 33 square. Now, what does 33 square look like? 33 square will be 3 square, that is 9, and 3 times 3, 9, 9 times 2 is 18, 8, and 1 carry 3 times 3 is 9, 1089 plus. What you get over here is 56 square. 56 square will be equal to what? 56 square will be 6 square, 36 over here. 3 carry, 6, 5, 30, 60 times 60 plus 3 is 3. 6 carry, and 5, 5, 25 plus 6 is 3, 1. 3, 1, 3, 6. This is what you get. In the denominator, you have 33 square. That's what you have. Right? Let's add them together in the numerator. And what you get is, let's take a look at this. 9 plus 6 is 5. 3 and 8 is 11 plus 1, 12, 2, 1 carry, and 31, 41, 42. This becomes 42. 4225 upon 33 square. This is what I get. 4225, yes, this is a number which is square of some particular number. Yes, what is that number? If you may recall some results related to squares of numbers ending in 5, you will realize that this is square of some number ending in 5. And 42 is actually 6 times 7. This is 65 square. So this becomes 65 over 33. Okay. So sec alpha becomes this. Therefore, cos alpha becomes reciprocal of this, or alpha becomes equal to cos inverse of 33 upon 65. And yes, that was the correction that I was looking at. This is not 35, this is actually 65 over here. Okay. We had to prove this equal to this 33 upon 65. And have we done that? Yes, we have done exactly that. This comes out to be tan inverse 56 upon 33, which is actually equal to cos inverse 33 upon 65. This is my RHS. Hence proved. Okay, this is my RHS and hence proved. Is it a long? No. Conversion of this and this takes least application of your brain, and basically you can get this result. Using this result, you can get the answer very easily. Using this result of addition of tan inverse x plus tan inverse y, you can get a result very easily. Okay, this particular method, when you look at this method is applicable throughout all questions of this kind. When you add 2 in ITF and you have another ITF on the right hand side, you can always convert in terms of tan inverse and get your result. But in case you have, let us say, cos and cos on the LHS and another cos on the RHS, you can use one more idea. What is that one more idea? Let me discuss that as well. This is theta and this is phi. Okay. So you're actually looking at cos of theta plus phi. Imagine this as cos of theta plus phi. That's what you're looking at, right? And what is cos of theta cos of theta plus phi equal to? Let's think that for a minute. Cos of theta plus phi will be equal to cos theta cos phi minus sin theta sin phi, which we have found over here, right? So you have found cos theta cos phi, you have found sin theta sin phi. You can use that to get cos of theta plus phi easily, right? And then take cos inverse throughout. What are we talking about? Let me write the steps in front of you. Let me write an alternative step. Will require these things, will require these steps still, but the alternative method would imply that we will not need to apply this one. Will not require to apply this one. Okay. So which one should we prefer? We should prefer this one, but then let me discuss the other one as well. Because you are sure to encounter those kind of methods as well. That method as well. What do we have? In the LHS, you have theta plus phi, right? Let's talk about cos theta plus phi first, right? Let's talk about cos theta plus phi. This is equal to cos theta cos phi minus sin theta sin phi. What does this become? Cos theta is 4 by 5, cos phi is 12 by 13 minus sin theta is 3 by 5 and sin phi is 5 by 13. What does that give us? In the denominator you have a 65, which is the LCM, right? This 12 4 48 and this is 15. This gives me 33 over 65. Oh, that makes life very simple, yes. This gives me cos of theta plus phi is equal to this, or you can say that theta plus phi is equal to cos inverse of 33 upon 65. Now what is theta? Theta is cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 35, and that's the complete proof of this question. That's another way in which you can tackle the same question. This is method 2, wherein we require this, and other than that nothing much as such, right? This is a complete proof of this question, and those are all the aspects which we wanted to discuss in this question.